let's continue to the topics of atoms, moles, molecules, particles, ions, formula units, and we go now to problem number 2. Here it is. Problem number 2 states that how many atoms of 24 grams of tungsten? Now, how can we attack to this kind of problem? Okay, we need to focus to the given. And it happens only that we have only one given, which is the mass. Okay, 24 grams of tungsten. Then automatically this will be our basis of calculation, the 24 grams of tungsten. Start with your computation with the 24 grams of tungsten. And now we will be able to use the dimensional analysis or conversion way of solving, not the standard way of solving by using specific and standard formulas and equations, because here, there's no specific formulas and equations to be used in the first place. Okay, now we start with 24 grams of tungsten. Okay, 24 grams of tungsten, W. Capital W is a symbol of tungsten. Okay, times, okay, like that. Now, see to it that you will multiply that with the denominator of grams so that it will be cancelled also. So you come to think of atomic mass of tungsten. What is the atomic mass of tungsten? So that is 183.8 grams per atom. Okay, it's gonna be like that. Now you will say 183.8 grams of tungsten. Now, you will write atom in the denominator or the mole. Come to think of this. You use this tungsten in a chemical reactions. So, you will transform the atom into the mole. Instead of gram atom, you'll be dealing with gram mole. So, the mole is your numerator here. So mole of tungsten. Grams, what is left is the mole. 1 mole of tungsten. Now, you are after to the atoms. So you need to multiply again this with a mole in the denominator so that you cancel the mole again. That is your first rule of thumb to cancel one of the units so that you can simplify further your answer. Okay, now I have 1 mole here, the numerator on the other side. Then, on the other side, I have also the denominator of 1 mole of tungsten, something like this. 1 mole of tungsten, okay, is equal to the Avogadro number in terms of atoms, so that you can now compute what is being asked in problem number 2. So we have 6.023 times 10 to the 23 atoms of tungsten. Now cancel the moles. What is left is atom. Now you solve the problem. How many atoms? Right? Now I cannot do this by my own brain cells estimation of the answer because it takes a lot of exponential to the raised to the power 23. I will use the scientific calculator to do this. Okay. Okay. So I have 24 times 6.023 exponent. 6.023 exponent. I will discuss later why. 23 times 24 is equals to, divided by 183.8 is equal to 7.86. Okay, 7.86 mga palangga. Okay, 7.86 times 10 to the, okay, 10 to the 22. Okay, this is your answer in number 2. There are 7.86 times 10 raised to the power 22 atoms of tungsten. By having this given 24 grams of tungsten initially. Okay, now I will discuss. Be careful here in your computation because it will matter a lot. Why? For example, if you divide 24 gram to 183 gram, and then Baden multiply that with 6.023. Check the answer. Okay. Now, version 2. If you take multiplying both the numerator all 6.023 times 24 and then later divide it with 183.8. So this now follow the PEMDAS rule in algebra. So it will differ in the answer. Okay? So go to the standard and proper way of solving. Okay. Do first here, okay, like this. Okay, like the Susbtances. Okay, tandas. Okay, parenthesis first. There's no parenthesis here, right? So equals. Okay, exponent. So we have exponent here, right? Exponent here. So use this exponent first. And then after that, multiply. Okay, so 6.023 times 10 to the 23, this is exponent. Then multiply that first to 24. Okay, third, division. After that, divide that 183.8. Okay, since there's no addition and subtraction, you will focus on the AMD in the PEMDAS rule of math, algebra. Exponent, multiplication, and division. Because if you divide first the 24 grams to 183.8, it may not yield the same answer with using this PEMDAS in algebra. For example, if you divide 24 grams to 183.8, then later you will multiply that with 6.023 times 10 to the 23 exponent, your answer may not be the same. Okay? So it will trick you out. So that's why you need to remember the PEMDAS rule in math, in algebra. This one. That's why I do first the exponent. I said, in my scientific calculator, I operate first 6.023 times 10 to the 23 exponent times 24 divided by 183.8 so that I yield the answer 7.86 times 10 to the 22 atoms of tungsten, because it may differ if I will use the other operations. If I will do first the 24 gram divided by 183.8 and later times the exponent, because you will not follow the PEMDAS rule in algebra and in math. And this is also the reason why some of the students also failed to, pass, because the basic rule they forgot in math. Okay, you get the point. And this is very tricky because the other part is in the left. Normally you will start on the left, not on the right. Right? When you solve something, division, addition, you will never clear. You will do first the basis of equation on the left before going to the right. But in this case, you do first the right because the exponent is in here. So that will be the rule. You will be just lucky if there's no exponent, there's no parenthesis. But in this case, there's a parenthesis. There's an exponent, 6.023 times 10 to the 23, the Avogadro constant. Be careful, mga palangga, ha? So this is part of general engineering coverage in engineering examination in the future. Okay, licensure engineering examinations are ruled and administered by Philippine Regulation Commission. Okay, in the Republic of the Philippines. Okay, now this is done already. Problem number 2, we had already the answer. Okay, now we go to problem number 3. Okay, you get the point, mga palangga. Okay, problem number 3 na mga palangga. Okay. So, problem number 3. Calculate the mass of one iridium atom. So, turo na kano iridium. Okay. So, I play around in my brain cells. I need to be unique. I don't need to be dependent on the books. I need to create my own problem. Really. Okay, so that I can, I can use, I can play around my, wild imagination in my brain cells as long as this validated that it follows really the theory and the concepts. Something like that. Okay, so I use iridium here. Iridium is a radioactive element under lanthanide series, the last rock in the periodic table. All of them are radioactive elements. The lanthanide series family and periodic table. Okay, get the point? Something like that. So iridium. Okay, iridium atom. Okay, calculate the mass of one iridium atom. So there is grammar in the first place because there is only one atom. That's why iridium atom, not atoms, right? There's only one. You get the point? English grammar. Now, calculate the mass. Okay, mass. Question mark. So, how can you calculate the mass having only an atom? You can connect the density, you can connect that to, molar density, molar mass, whatever formulas, standard formulas we encountered before. You can use that. Okay? Now, the only thing is to remember always the Amadeo Avogadro constant. Always. Okay. Now, Calculate. Start with one iridium atom. Charot. Okay. One atom, okay, ganun-ganun, di ba, mga kalangka? One atom of iridium IR, okay, like ganon, okay, like that. So, there is one atom, okay, of iridium. Okay, what is the atomic mass of an iridium? Okay, what is the atomic mass of an iridium? That is 192.427. So dapat mag-memorize ka guys ha. 192.47 gram per atom. Then it will become gram per mole if you involve that in another chemical reaction or in a compound, but we stick to the atom pa talaga siya. Okay, so one atom of iridium that's 192.427 gram, like that, times one atom, there is 6.02 Avogadro's number. 6.023 times 10 to the 23. Cancel atom, like that. What we left is the mass. Okay? So calculate. Okay, like this. So 192.427 divided by 6.023 exponent to the 23. Our answer will be 3.19 raised to the power negative 22. Wow. 3.19 times 10 to the negative 22. Okay? Like that. This is the grams of iridium. Okay. Very easy, right? Calculate the mass of one iridium atom. So if the question in the future in the examination will change, they will give another element, chlorine, like the whatever, same technique how to use it, involve the concept of the Avogadro constant, something like that. Okay, so number 3 is already solved, right? Any questions so far for the problem number 3? Nothing, right? Okay. Now, before going to problem number 4, I hope you can share this video to senior high school students who really enjoy chemistry nowadays in their present topic. Okay, and then also for the first year college students under General Chemistry Lecture 1. Okay, thank you so much. You can comment down below in the comment section. You can also subscribe my YT channel if you want also, and you have full freedom to do it. Of course, I will be very, very happy if you do that. And then you can click the bell notification for some news updates of I am a singer, eternal voice, a YouTube content creator, and a small YouTuber. I emphasize the adjective small. Okay? So that walay away. Okay? So, or gonna be like that. God bless everybody. Bye-bye. See you later. Ganon. Nakakaloka.